All right, being the last one, I will try to not talk about simulation, and I won't. I'll be talking about Industry 4.0 and AI. I'll try to be more brief, actually, on the introduction. Who here feels like AI should be part of their strategy in their company in some way or form? All right, keep your hands up. Who now thinks that they actually have a strategy in place at their company? Okay, that kind of matches what we're getting. So AI has been the talk of the town the last years, a lot of hype about it. Just 3 years ago, AI wasn't even the top 100 most searched terms on Gartner, and now you see these pictures of brains everywhere, and everyone's trying to market their AI and what they're doing in AI. So again, I'm a project guy. I'll probably present to you guys, I'm going to present maybe 5 different projects that we've done related to IoT and AI. Just before alluding to what you guys just said, most executives think that AI is going to be a huge transformation and they need AI in their projects, in their corporate plan to maintain a competitive edge. But the reality is that only about 39% of them actually have a plan or an idea of where they're going. And the reality is actually only about 5% have actually extensively adopted it. So the gap between the reality of, oh yeah, we should do something and exciting, and oh, what do I do and how do I do it, there's a big gap between that. And there's a lot of hype around it. A lot of people are thinking about AI and self-awareness. So what I'm not going to talk to you guys about today is this type of AI, self-aware type things. At Maya, we're much more concrete. We're much more tackling machine learning. And I almost don't like the word AI. I use it because it's simple, but I find it very too overall encompassing versus I think machine learning is just learning off of data. It is much more realistic and concrete, and that's actually where we apply a lot of our projects and where we call it applied AI or applied machine learning. And we're at Maya really focused at applying that to engineering, manufacturing, and operations. That's the type of data that we're trying to look at. And so a bit of AI 101, just one slide for those who haven't touched AI. Typically what we're looking at is supervised learning projects, so data that's labeled. And from there, we're either looking to predict the label, so if it's failing or passing or a certain criteria, or predict a performance number. Those are the type of things that we're looking at. So you'll often hear supervised learning or unsupervised learning if things aren't labeled. We do projects in there as well. But it just gives an idea. There's a big space, a lot of stuff there. I'm not covering everything. I'm just going to talk about specific applied AI projects on there. And just a little bit of background so you understand how did Maya get into this. The machine learning isn't that new. It's been around for 20, 30 years. It's really just been availability of data and computational power that's made it accessible recently. So with Maya's background, just numerical solvers, mathematics, and science, this wasn't a far stretch. And actually, we kind of deviated into that from leveraging what we're doing in Siemens and doing different real-time monitoring projects that I'll get to in a second. And from there, once we had data, we started analyzing it, it kind of just became a natural flow to start applying, statistical methods and machine learning methods from there. And that's how we ended up in that space. So let me just talk about a few projects that we've done. The first one is actually at eBay. So we actually built a digital twin of their data centers. One of the problems that eBay has, and a lot of data center has, is to forecast their growth. And their growth on many aspects. The space that they need, the power that they need, the cooling equipment that they need. And that's hard for them to forecast due to a lot of different reasons. So what we ended up doing, what you see here is actually, this is a custom 3D view of one of their data halls. And every asset that you see there's a rack and there's servers and there's different equipment in there, is actually connected to real-time points. So we're using a real-time data acquisition system, and we can interrogate the time series history of all these data points and aggregate them together. And the challenge they had is that because they have multiple data centers, multiple projects supporting different initiatives, they couldn't conglomerate that together to forecast and order their equipment and expand at the right speed. So we created kind of the centralized hub inside the digital twin of their data center to improve their capacity forecasting. And now that's what they're using today actually to build out their next data centers and plan how much power that they need. Or if they put, often you could put, how do you say, denser equipment, more equipment per rack, what's the heating, cooling capacities that are required. So this is an example that we've done with eBay. Also related to data is a company in Canada, Canada Steamship Lines. It's basically a shipping company where they have about, I think close to 60 ships worldwide, but we're working on about 35 of them. So these are these large bulk carriers that could carry, I think, 35 metric tons of material, about 750 feet long. An old company, 150 years old. They do not have any data acquisition or anything. Well, a few years ago they didn't. And they came to speak to us and say, hey, this AI thing, what can we do? And we said, you have no data, we can't do anything. So they were a little disappointed, but from there, that's how we got them on an IoT roadmap to start deploying tools to collect data. So we're partners with a company called OSI SoftPi. It's one of our other partners. They're a real-time data acquisition system. I won't go into the details, but in a nutshell, we're very strong at connecting to a lot of different protocols, whether it's automation control systems in a factory or a BMS, to different mobile technologies or remote sensors. We can connect to over 450 different protocols. So Maya can set up this system, pull in the data, and data archive all the time history series of that, and then connect that to like Teamcenter or any other digital twin information in Siemens technology. And at the end of this, it's very big in oil and gas, is dashboards that look like this. This is what you'd see typically in a operational center, in a data center, or in an oil and gas rig or stuff like this, is all the information coming in. So what they wanted to do is apply machine learning to their fleets and to their ships. So they had we've been working with them now for almost 2 years on a project called O2. So it's to optimize operations, to look at vessel performance and fleet performance. And from there, it's a lot of use cases around geofencing when the boats are navigating around. If they're going to be 2 hours away, they're going to hit some locks. Do I accelerate to get in front of the next boat, burning more fuel, but then I'm going to spend less time waiting and I'm going to get to my final destination faster? Stuff like that. Or do I slow down, save on fuel, because I'll be waiting in line anyways when I get there. Okay? So there's a lot of different rules like that in navigation that can help the companies be more efficient at burning less fuel and save money, et cetera, and nice environmental aspects as well. So right now we're currently configuring, we're deploying on each ship an IT stack. It's a small rack that is connecting to all their sensors on board, and we're pulling about 500 data points per ship. So that's fuel consumption, positioning, oil, pressure, connected to different of their equipments, their backup equipments, and we're pulling all that so that we can target use cases around predictive maintenance, operational aspects, et cetera. And so this is really enabling them to then eventually be able to do more machine learning. So right now we're just in that process, start collecting data so that we can build on top of that. So at the end, this is where it looks like right now. We have a few dashboards up and running on some of their boats. So this is kind of like a ship set dashboard. Resistance to change, I think we were talking about that earlier, is difficult right now. So we're not telling the captains what to do because they know what to do and they've been doing it for a long time, but we're more like giving them tips and tricks. Like, oh, you can't dump here, we're in a certain position in the channel, you can't empty your waste here, you gotta wait till you're somewhere else or stuff like that. So we're doing analytics on board, and then we're doing centralized analytics. So right now the architecture is we're collecting from all the different boats, bringing it to a centralized HQ in Montreal. And this is like one of their dashboards at the headquarters in Montreal where they can see different boats. And if they're going through specific maneuvers, they can't actually talk to them. They say, oh, I can call this boat now, I can't call that boat now, they're busy, et cetera. So this is really about instrumenting companies with an operational solution that then they're going to be able to do machine learning from. All right? But once you have data, what can you do with it? So, oops, I want to preface that next very busy slide. So the next slide is very busy because it was an executive summary that was put together. And one of the challenges around AI is actually educating people about AI. The expectations sometimes are a little disconnected from reality. And then when we find something, people are gonna be like, but how did you find that? And sometimes it's hard to explain how did you discover something in the data and if you actually want to make a business decision on it. And that was actually our first, we tripped a lot at that first. Our first consulting projects when we were working with customers to explain to someone, no, you should change these parameters in production. You're going to get a better output. But why? Because some neural network told us so that we figured it out. So figuring that out has been a little bit tough. So I'm going to show a very busy slide that was meant as an executive summary, but I'll walk through it after in a few next slides. So this is basically the 5 steps that we typically take when we're working on an AI project with our customers. I'll walk through them in a second, but it basically comes up to 1, let's make sure we have a very clear use case. What are we looking for? Is it a quality problem, a production problem? Let's be very specific as to what we're looking for. 2, it's, okay, do we have the data that we need to support that? And is it structured the way it should be that we can actually do some analysis on that data? So then we prepare that data. 3, it's, okay, let's just bombard it with data science. Let's play with it, flip it around, turn it around, figure out if the data is clean it out, and get some results from there. The most critical aspect, though, is then working with a subject matter expert, an SME, so not small, medium enterprise, but a subject matter expert. And that's kind of the song and dance that's most crucial, because a data scientist will pull some correlations. It doesn't mean it makes sense. Okay, so we have to work with someone that knows the factory or the machine or the product to say, oh yeah, that does make sense. I didn't think of that, but it makes actual physical sense. It's just not a statistical fluke, basically. And then at the end, it's basically turning that into a result. So this specific project is around discrete manufacturing. The problem was that the customer was building a quite complex product that was a combination of chemical process, mixing some stuff, and assembling it together in mechanical assembly. And they could only test their performance multiple stages into that assembly process. So later on, they'd get a rejection rate. They'd get a product that was rejected, that failed, and then the cost of disassembling that and the chemicals that were involved made it quite costly, actually. And that was a problem. And they didn't understand where the failures were coming from. So what they had is about a 10-stage process, and they didn't say, where is this error coming from? And they've been tackling it for years, and they weren't sure how to do it. So when we spoke to them, like, hey, we understand very much their data. They were running on that OSIsoft Pi data system that we were talking about, so let's tackle it. So they had about 20,000 data points in their manufacturing line. That's, production rate, speed, pressure, temperature, nozzle velocity, film thickness measurements, a whole bunch of stuff that was pulled out of all their different stages of manufacturing, as well as they had the quality of, in an SQL database, of what was rejecting, what was not rejecting. And so we had to map all that together, because maybe the initial was, I don't know, maybe 100 components, but the failure rate is maybe on one assembly of 100 components. So we had to map, it's kind of like a tree structure of data to a final end product. So once we had mapped that, we started with a whole bunch of neural networks to analyze the data and map, okay, can I figure out which variables out of my 20,000 are contributing to that failure rate? And we ironed that down to about a top 50 features. Well, we went from 20,000 down to 1,000 to start because we weeded out some easy ones, but we brought it down to about 50. And then from there is where we started working a lot with the subject matter experts. So we were looking at what was directly correlated or inversely correlated in terms of features, and then looking at individual rejections. So for example, one feature you could see based on, I don't know if this works here, a certain threshold in that, maybe temperature or pressure, we had much higher rejection rates. So that's kind of easy to nail out. What was interesting was when you start correlating two of them, and then you start saying, okay, there's a zone here that these two together, maybe this value when this one's low and this one's high, it passes, but when they're both low, I'm getting a lot of failures here. So we started kind of finding all these little interesting tidbits of information that were saying, hey, if we could calibrate better the manufacturing line setup, we'd probably reduce the amount of rejection. And so that was basically the outcome of the project. We'd figured out that in the early stages, we'd figured out that 77% of the failures were caused in the early stages of production. And right now, that's where we are on the project. We're actually in the process of trying to how to roll this out into production as an AI that's monitoring this. And we're trying to figure out, do we want to change the variables in production or flag it? So we're at that step 5 right now, working at the customer doing this. So this just gives an idea of what can be done with AI, but it was a very specific case, and that was what was important, is that we had identified the use case that the customer wanted to do. The next two projects are more ongoing projects that we're doing right now. So this is a manufacturing example. The next one here is more of doing AI on top of simulation data. The example here is a generic example of the project that we're doing those with the Canadian Space Agency right now. Satellites that are flying around in space or that are going in through interplanetary travel have long thermal cycles, hot and cold, hot and cold. And to simulate those is quite heavy. So the idea of using reduced models in simulation to simulate those long transient simulations, we pitch to them as maybe we can have an AI that replicates the thermal behavior of satellites. And so what we're working on right now is how do we generate enough simulation? What's the right amount of simulation data that you have to generate? Then after that, you can have an AI that mimics that behavior of that assembly. So as an example here, this was one of our first prototypes to see how we could do it to get us a feel. But we just took a multi-channel fluid flow assembly that took about 15, 20 minutes to simulate. That had about 5 key variables to do. And we used simulation to generate data. Instead of operational data, we used simulation data instead, and to generate enough data. And at the end of the day, something that was taking 15, 20 minutes to simulate, we were able to come up with an AI that was accurate about 99% of the time, or 99% accuracy, sorry. And then the result was instantaneous. It was 1 second because it was just a matrix basically that you're feeding. So, and the behavior that we were able to mimic was quite complex. You can see this type of I forget which facet it was, but we had some interesting behavior there. And the blue line is actually the mimicking behavior of what we were able to predict. So the efficiency gain was quite large. Now we're looking at saying, okay, well, what type of benefit this has? It's kind of like a surrogate model. Can we take a systems engineering model and actually build an AI instead that mimics a whole system? So these are the type of areas that Maya is exploring right now, either through R&D projects with government or with different companies around applying AI to simulation data, basically. And the last project I'll present, this is kind of similar to some of the projects that I was talking earlier about predicting cost of manufacturing parts. We had an SME now, a small medium enterprise, approach us. They were struggling to predict the cost of their parts. They had Excel sheets with all these rules, and it was messy and unreliable, and there was mistakes, and people are always fidgeting around with it. And we had the idea of saying, well, why don't you just dump us a bunch of your parts? We're going to use some custom development work that we can do to extract all the features inside those parts and characterize the parts. So we can classify all the parts with the amount of features that are manufactured in it, and they actually have the final actual manufacturing cost of those parts. So this is an ongoing project. We don't have the results yet, but this is something that we're starting recently, is to how can we accelerate the coding process, but just purely on an AI that's gonna learn on past manufactured parts. So this is more an example of AI now applied to manufacturing and CAD parts. So for the sake of time, I won't present the next example, but this was a related, similar process to, it was anomaly detection basically inside operations. But again, a similar process we've done around fleet management there. So I'll skip that. A last just note on MindSphere. If you haven't heard about it, it's Siemens' IoT platform that's cloud-based. So we're a partner on there, and the key thing is there's 3 components to it: collecting data. So they have interesting solutions around the hardware that you can actually put on your equipment to pull that data and send it to the cloud. Small boxes in the order of a few $100s that you can actually pipe data to the cloud. And then from there, there's actually like an app store that people such as Maya and other companies and partners are building apps that companies can leverage, either for anomaly detection, AI, dashboarding, fleet management, stuff like that. So that's something interesting to consider. So to wrap it up, I'll just say a few things on being AI ready. This is something sometimes we do workshops with our customers. What does that mean? There's just 5 things to being AI ready. One of them is, like I said before, having the use case. 2 is the data. Then having the tools and techniques. But then once you have that, is how do you deploy and integrate it into your organization? So you need to have workflows, and what does that mean in your organization to have an AI supporting a business case? But also having the culture, educate the culture around that, because there's still, I think, unknown. I personally feel that we'll fast forward maybe in 10 years, and there's a simulation department, there'll be a data science department to support a lot of projects. That's what I would foresee. But I still think we're learning how does that work, and what are the tools, and what is the nature of that practice. So getting started, first thing, again, define your use case, and data. That's where the discussion starts all the time. Rule of, good data with a simple AI will beat poor data with the best-in-class AI every day. Actually, a lot of the times that we're doing AI projects, I'm still using the word AI, but it's simple regression models. They're not very complicated. Usually people want to go, yeah, let's throw a deep neural network on there. No need to overkill it. That's actually quite rare that we need to go that far on our projects. Correlation is not causation, so I like this example. It shows the consumption of margarine is directly related to the divorce rate at one state in the US. So it seems that the more margarine you eat, the higher chances you have of getting divorced. I guess that makes some type of sense, but obviously there's absolutely no relation. So that goes back to the example before. You need to get your subject matter experts involved, because if you're just looking at it from a pure data science point of view, you're going to be thrown in all types of directions. And I like to show this example. Get your SME involved, and we've been down that path in our first projects, kind of all excited, hey, we found some correlation, and we spent all this time going in the wrong direction because the data was pushing us in that way. And then the guy was like, what are you talking about? That makes no sense. It's impossible. Oh, shoot. Okay. So you have to work, the data scientists and the subject matter experts have to really work close together so you can control your analysis process, or else you'll just be thrown in the wrong direction. And you got to be careful. There's unintended behavior. I thought this was pretty funny when I don't know if you guys saw the news here, but Amazon, their Echo Dot was just started laughing at some of their people randomly, and they didn't know why because it was AI driven. So you can get some unexpected results. I haven't found that yet in engineering data, but who knows? We'll see what happens. And again, AI is no match for natural stupidity. Again, it's so easy to just think. I have people, we speak with customers and they'll be like, can we just throw an AI on that? I'm like, what does that statement even mean? Like, so you got to be careful what you're doing with the data and the decisions that you make. And so so in summary, we like to do a lot of cool projects with our customers. And if you guys want to be a little bit more in line with what you could do or where you could go, we'd love to have that conversation. So again, define your use case around efficiency. Key takeaways to get started. I think the best thing to do is define use cases around quality and efficiency. Focus on good data. Get your SMEs involved and start small and targeted. Really focus on a small project is the best way to get going. All right. So I'm just starting the daily. Is there any questions on that AI section before I wrap up the day? I'll be available over lunch if people have questions. So just earlier I talked about, we've seen a lot of stuff today, whether it's the AI projects I just showed or simulation, automation, digital twin, et cetera. How do you get started? Of course, I'll preach a bit for Maya. I'm really proud of the type of work that we do and the type of projects that we've done. We cover the full breadth of engineering software like we saw before. We have a wide range of capabilities, whether it's from just assessing where you are, to training you, to deploying you, to configuring it, to doing some of the work for you, to customizing it. We really cover that whole breadth of activities. And we're really, we're mostly engineers. I think 75% of our company are engineers. So we're typically very result-oriented. We're not trying to sell hot air. We're trying to actually do concrete projects. And that's what we try to figure out early on in the stage of when we engage with our partners and with our customers. Again, just walking through it, make sure I didn't forget anything. Training and mentoring type of activities, process automation we spoke about today. All cycles of PLM implementation and deployment we cover, and a lot of specialized software development. Again, leveraging what we've been doing with Siemens for years, it's usually put us in a good position to really provide that fine, sweet spot. If getting stuff out of the box versus something that's custom, you want to make sure you have that sweet spot so it's sustainable for you guys to go in the long term. It's maintainable, and that so you guys, it makes sense for your company to adopt that technology. And our approach, we spoke a lot about Agile. We do both. So typically, the larger the project gets, Fumbi's absolutely right. It's hard to define at the beginning what you exactly want. And when we've done projects where we just do a big functional spec and develop for 8 months, usually 8 months later, it's not exactly what the customer wants. So we do both. If it's a small project, we can just do like a one drop. We'll do a functional spec. We'll align on that. If not, we also work in an Agile format with our customers to make sure that they're actively involved in what we define for them and it meets their requirements. So last slide for me. We saw a lot, but there's typically 3 ways that we get involved when we're starting to work with you guys. First one is if you don't know what you want to do or you don't know what you can do, we usually start with audit type activity. So this is all tailored to depending on what department you're looking at. So we'll typically target a certain scope, a workflow, a team, a department, and from there we'll engage with the key stakeholders, map whatever tools they're doing, whatever processes they're doing, validate that as to what we've seen elsewhere, best in class, or what we feel is possible compared to what we've seen elsewhere. And the result from that will typically be some recommendations. Hey, this is where I would prioritize, making some changes in your organizations. Here's where there's opportunities. This is probably the type of ROI you can expect. This is where the list of priorities and how we feel we could help you tackle them. That's one first way. If you do know what you want to do, and you have very specific business cases like we saw earlier where Husky wanted to automate a workflow to enable their salesperson, Typically, we'll start more with a solution alignment. That's more of a, we'll engage specifically with your team to define that solution, come up with a project plan, its cost, its maintenance plan, everything surrounding that. And the result is more of, here's a functional spec, or at least the first version of that, and here's a commercial proposal. How can Maya actually engage and help you deliver that? So that's more very specific to a problem. And related more to the AI, we do more of an AI readiness type activity, more of a discovery type workshop with you guys. So it'll be more of an activity where we'll help define some business use cases that make sense. Look at your current data map. What do you have that's available? What's its maturity? What's the quality of that data? And start educating our customers on, okay, how could you get there? What are those around? What's that about? And the result of that type of activity is typically either an AI discovery project. Hey, let's do one first AI project, something small, 1 or 2 months of work, see if we can actually do something with what you have. If you don't have the opportunity to do that, okay, let's figure out a data governance plan. How should you structure your data? How could you collect more data? Or where are you with respect to data today? Or if you don't have anything, well, that's kind of what we did with Canada Steamship Line. Let's put you on a 4.0 plan and see how can we help you deploy a solution that could help you capture your data. So these are kind of the 3 areas, kind of starting points that you can work with Maya, depending on what your interests are and what you're looking to do. And I could speak to you in any more detail after that.